Okay, so today we're going to learn about actually making a box and whisker plot, which is another graphical representation of looking at data. And we talked about statistics last week and how in order to visualize it and take something very big and random like a bunch of numbers and make sense of them, we use visual representations, and this is one of them. So in the vocabulary box you can see that it defines what it is. It's a data display that organizes data values into 4 parts. The lower quartile is the median of the lower half. The upper quartile is the median of the upper half. The lower extreme is the least data value. The upper extreme is the greatest data value. The dot that's in the middle of this plot, so it's kind of, let's see what we can do here. Right here is the median of the entire set, okay? And then this is the lower quartile, the upper quartile, the lower extreme, the upper extreme. So you first plot those on a number line. So you have to represent it on a number line that has an equal interval so that then it gives meaning to it, because you can tell that maybe that median of the whole set of data isn't in the middle of the box. So that's going to tell us something, right? Because each section now from here to here is 1/4 of the whole data. 1/4, 1/4, and 1/4. So it's representative, meaning that each section is 25% of the total amount of data there, and then we can make some interpretations based on that. So we're going to learn a little bit about that and how to do this. So the first thing we want to do is example 1, where we actually make the box and whisker plot. And it says that the length in minutes of some songs on a CD are listed below. Make a box and whisker plot of the data. So here's some random numbers. Again, we're not even sure what they all mean, but if we make a box and whisker plot of the data, we can make sense of it. So the first thing we want to do is to put the numbers in order from least to greatest. So go ahead and put the numbers are already in order from least to greatest on your paper. All right? So with that information, then we want to find the middle value. So to find the middle value, you can count the number of data points. And since it's an odd number, the middle value falls right in the middle. So this is the median. What would happen if there were 2 points in the middle? So now with the middle number, sometimes I circle it because I don't necessarily include it in what I'm doing next. This becomes the upper half. And if I look at those 5 numbers, this number, 4.1, becomes the upper quartile, and this 4.5, the upper extreme. Here's the lower half, and here is the median of the lower half, which is the lower quartile, and the lowest value is the lower extreme. So notice that they've graphed it for you, and I'm not making you draw it this time, but let's point out what everything means. You have a number line, and the number line is equal intervals going up by halves. So the first point you put on the number line is the median. You can see that right here. So they graph 3.7. The next number they graph is the 4.1, and then again the 3.1. So they do the quartiles, the upper and lower quartile and the median, and then they draw the box around those. Then here's where the whiskers come in. The whiskers, and they said to draw the vertical line through the median. That's another thing you do. Then you put a dot where the upper and lower extreme are, and you draw the whiskers. Just connect them with a line. For example 2, we're going to be making some inferences and interpreting the box and whisker plots. So you're researching the fuel efficiency of different kinds of cars and trucks. The box and whisker plots show the fuel efficiencies in miles per gallon for the vehicles you researched. The question for A, about what fraction of the cars have a fuel efficiency between 16 and 24 miles per gallon? So since the left whisker in the plot for cars is between 16 and 24, it represents 1/4 of the cars with that fuel efficiency. So the solution would be about 1/4 of the cars have an efficiency of 16 miles per gallon. Okay, let's look at question 2, or B, about what fraction of the trucks have a fuel efficiency between 16 and 24 miles per gallon. Is that the entire plot, ooh, I don't know what happened there. The entire plot for trucks is between 16 and 24. So all of the trucks have that efficiency. Let's look at part C. In general, which type of vehicle is more fuel efficient? We're going to say that notice that the large box and the right whisker in the plot for cars is greater than 24, and this accounts for 3/4 of the cars. So since 3/4 of the cars are represented, they are more fuel efficient than all of the trucks put together. So cars are more efficient than trucks. In the final example for today, we are going to actually make a dot plot, a box and whisker plot, excuse me. So in the recent week, Terrence jogged for daily times of 40, 35, 45, 48, 36, 42, and 40 minutes. We are going to make a box and whisker plot of the time. So the first thing we want to do is start by putting the numbers in order, least to greatest. So everybody put those data points in order, least to greatest, on your paper in the space provided. So the smallest point is 35. Then we have 36. I see 2 of the 40s, so I'll put a 40 and a 40. And then I have 2 42s. Ah, you are right. One of them was a 45, so let's change that. And finally, a 48. I always like to double check. 1, 2, 3, 4, 5, 6, 7. 1, 2, 3, 4, 5, 6, 7. Okay, in this example, again, we have an odd number. So the middle value here is 40. That represents the median. Okay? These numbers represent the upper half, and 45 would be the upper quartile. Okay, these numbers represent the lower half, and 36 would be the lower quartile. 40 is the upper extreme, and 35 is the lower extreme. So I need a number line that's going to get from 35, I'm just going to go ahead and maybe count by 2's. So this is important. When you make your number line, it has to be equal intervals. So let's start on 34, 36, 38, 40. 42, 44, 46, 48, and 50. And then if you want to, then you can start plotting your box and whisker plot. So the median set of data is at 40. So I'll put a dot right at 40. Then I need a dot at 45, which will fall like halfway in between right here for my upper quartile. And then I need a dot at 36 for my lower quartile, and then this is where I draw the box. And remember to put the line here. So then you also need to extend out a dot to the whiskers to the upper extreme and to the lower extreme. And if you want to label them underneath, you can, but you don't have to. So we've gone ahead and drawn the box and whisker plot for the daily times for Terrence.